Swayam Prabha. Digital India. Educated India.
Moving to the next one, let's talk about what we are going to discuss here. Is there anyone that taken a course in optimization? Self-study? Okay. Yeah, so it looks like most of you didn't, but of course in your high schools you have optimized a function. You found the minimum of a function, maybe one variable, two variable functions. That's the beginning, but I teach a full semester course on optimization. There are lots of universities where optimization is taught. For some reason in India, I taught in IIT Kanpur for 20 years until about 2011. So I introduced the course, and before me there was another professor, you may have heard his name, called S.S. Rao. He's got a big book on optimization as well. So in IIT Kanpur there had been a tradition of doing optimization, but I have not seen that in many other IITs or IIScs. But you will see soon how important the topic is. So, but I don't say too much about it because at my university I try to do that, say that let's make it at least an elective for every engineering discipline. But then the board of trustees, I had to make a presentation. They came back to me and said, "That's a very good idea. Why don't you teach?" So that's always happens. If you say some idea, then the whole onus comes to you. I said, I cannot teach the whole engineering. This must be about 2,000, 3,000 people, right? Students. So, but I think there should be more effort in trying to make this optional for some disciplines, but compulsory for certain engineering disciplines, including electrical, mechanical, civil, some basic ones, like where the design is a big issue. And I think Dr. Ramu is in the design department here. Design optimization is really something that you have to do. Sorry, I have a little voice problem. During this time when I come, because of the dust and all, I always have this issue. But I think we are trying to fix the microphone. And but can you hear me at the back, right? Yeah. Okay. All right. So this is we're going to talk about what is optimization. So let me just give you a very brief idea before I go into the details in lecture 1. So we'll be talking about single criteria optimization, which means there is a single objective function. If you think of some variables, which I put here as x and y, there's just two variables here. So if you have two variables, you can have a two-dimensional space, right? If you have 100 variables, you have 100-dimensional space. Of course, we can't visualize that easily. But in that space, I can choose few points. Now, point here means I can always have a x and a y, right? So any point I put there, I know what is x and y. But now that point is called a solution or a point or an individual. There are different names, okay, or sometimes solution. Now I need to say this point versus that point, which is better. These are two different designs. You see, my x and y values are different. So if I am designing anything, and these are the parameters, dimensions, when I go to solution 1 versus solution 2, solution 1 will look different than solution 2, right? So any point I pick here, you'll have a different looking solution. So obviously there needs some performance measure which will say how good is this one versus 2 or 3, right? So I need an objective function. That's where this criterion comes in. So let's say I've got a criterion here. This could be cost. So cost of producing that design, or it could be environmental effects. It could be many other things that I can think of. Sometimes I can maximize as well. So once I decide what is my objective function or criterion function, it could be something like this surface or function that you see around here, right? So that is already defined, and you are, as a designer, you're going to say you are minimizing cost or minimizing whatever. So now at this point I can compute for x and y, I can compute what is the function. So I need a function like this, f, which is a function of x, y, z, whatever are the variables I have, right? Who is going to supply that? As a designer, as an optimization person, you are going to supply that. because the optimization algorithm doesn't know what you want to do. So once you supply that, let's say for this one, it's basically saying how much do I go up to get into this surface? That's my value, that's my fxy. For this one, it could be this much. So now for every point, I have a way to define the z-axis, the cost value, the f value. With that now, I'm interested in finding a point that's going to make the function value minimum, because this is the one I want to minimize. That's the whole concept of optimization. There is one other thing which I have not mentioned here, constraints. I will do that in lecture 1. So when you have a single f, okay, that's called a single criterion or single objective optimization. Okay. Now let me see, I'll go this way. You can also have multi-criterion optimization, where instead of a single function fx that I showed you, you can have one f which is cost dimension. It could be f1 as a function of xy. This could be another function which is comfort, in this case I put, which could be f2 as a function of xy. I want to minimize this function, I may want to maximize this function. Okay, it doesn't matter, I could do that. But when you have more than one criteria, you get into now what is known as the objective space. So this is the objective space. You have f1 on one axis, f2 on the other axis, f3 would be on a third axis perpendicular to the board. If you have 10 objectives, I cannot show you here, but you can imagine there will be a 10-dimensional objective space. So you do have the variable space like x1, x2, x3 and some space here, and you take a point, you get x1, x2, x3, which was like 2-dimensional I showed you in the previous slide. But if you have 3 dimensions, it will be like something like this. Each point here in the single criteria had one objective value. Here I will have 2 objective values. So this I can put it over here. I can map it. Once you have x1, x2, x3 you give me, I can compute the cost, I can compute the comfort, because I know these functions. I have supplied those functions, so I know them. So I can get the point on the objective space. So it could be this point, another point could be over here. So like that, right? So there is a new space that comes up when you have a multi-objective or multi-criteria optimization. Okay. Now there it was easy to see where the minima is, because wherever this function dips the most, that's the minima, and our goal is to find that minimum point xy, x star, y star. Here, where is the optima? It turns out that the minimum of cost is, if this blue region is the entire, all of those points if you take and try to project, let's say this hypothetical blue region comes up here. There is no point here, 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 here or anywhere in the white space. Okay. So that's the bounded space you have on the objectives, it's objective space, and all of these x values are mapping there. Which one constitute the minima for multi-criteria optimization? The answer lies here, that what is the minimum for cost? If all of these blue regions are there, I'll try to make it a little interactive so you can also speak. Don't worry about if the answer is wrong, okay, just say whatever you think is logical. So if this is my blue region, which is all points from x space goes there, and I'm asking you what is the minimum cost solution over here, can you point me that one? Is this one 1.1? Because you see, out of all of these points, this gives me the minimum. There is nothing here, no blue point will come here. So this is the minimum f1, so that's the minimum for cost. And this car may look like this. If it's a car design I'm doing, there may be 500 parameters there, but that's how it will look like. Because when I put x1, x2, x3 and design the car, that's what it's going to look. Its performance is going to be only 10K for the cost, but if I look at the comfort, it's about 40%, which I'm not very happy about, because I also need to maximize. So now let's talk about maximizing comfort. What is that solution? Solution 2, because that's the maximum you're going to get, nothing beyond that. No blue points is going there, because I said there is no solution from here is going to be in the white space. So that's the best you can get for comfort. You cannot get 100% comfort. With the objective function, the way you have designed it, the way you have restricted your x1, x2, x3, there doesn't exist one, but that's the maximum you're going to get. Okay. So are 1, 2 or both optimum? we'll talk about definitions and all that when you get to multi-criteria, probably tomorrow. Yes, so both of them are optimum. It turns out A, B, C are also optimal. Anything that falls on this boundary of the blue region, the red line as you see there, are all optimal. So when you have multi-criteria optimization, there are multiple optimal solutions. There is no single one. Okay. So, but why I am calling them will, again, the definition will tell us. But let's say we pick this point and see why this is not optimal. This is not optimal because if you say this solution is D, I can give you a solution A, which is, you see, better than D in cost. A is better than D in cost. A is also better than D in comfort. It has a higher comfort than D. So D is definitely, if these two objectives are the only objectives you have, then D is definitely not one of the optimal solution because A is better than D in all respect. Like that, if you give me any other solution here, I can give you a suitable point on the red line which is better than one of the interior points in all objectives. In that sense, all the red points are optimal because if I give you A and you say no, B is more optimal, or B is, yeah, A is not as good as B. Can we say that? No, because you see, A has a smaller cost than B, but B has a better performance than A, right? So I cannot say which is better. So all the points, any pair of points on the red line, you have that situation. We cannot say which is better than the other. In that respect, all of them are optimal. But if you give me any other point here, I can point out a point on red line which is better than that point in all objectives. So in that sense, the optimization has a meaning. So you basically start your search somewhere here when you randomly put, and this solutions has to go to the Pareto set. I think probably go up. Yeah, I go to the Pareto set. This is known as a Pareto optimal set or Pareto optimal front. There are several names for this. I'm going to define all that as we go along. Okay, so that's the difference between single criteria, multi-criteria, and we're going to talk about both here in this course. Then there is evolutionary optimization, which I'm going to spend quite a bit of time, maybe starting today or maybe early tomorrow. Then there is a way to do evolutionary computation also for multi-criteria optimization. So in short, we call this EMO. Major part of the later part of the course is going to be on EMO because these are emerging topics, lots of research ideas are there. So I'd like to talk at least some of those ideas so that if you want to take up research in this area, you have some ideas to work on. Along with that comes multi-criteria decision making, because let's go back again. So optimization can find number of points on the Pareto set. Okay, so let's say I find 10 points over here, starting from 1, ending up at 2, and maybe some uniformly distributed set of points. So I get a good idea of how my front, Pareto optimal set or Pareto optimal front looks like. There is a difference, although I'm mixing it here. Pareto optimal front are the points on this objective space. Pareto optimal set are the points over here, because each of these points, maybe 1 is here, 2 is here, A, B, C is there. So they may line up in some way because each of these points are coming from there, right? These points are known as Pareto optimal set. Together they're called a Pareto optimal set. Okay, but once you find these number of points, somebody has to pick one, because you as a buyer of these cars, you have to go and say, I want to buy B, or some people I want to buy A, right? You have to make that decision. But what the designers like in the auto industry can do, because every one of you will have a different need, because some of you may not have that kind of money, maybe have this kind of money, but you know you have to compromise on the comfort or safety or whatever is on the other side. But some people may have this kind of money and they say, okay, I like a very good, comfortable, safe car and I'm willing to pay so much, right? So designers do not have the luxury to put one car for everyone. Okay, so if you go to any auto showroom, you will see line of cars, okay, one after the other, and each one of them has a price tag. So that's this. Maybe there are 10 solutions they have with different price tags, and each one of them you can learn about it from the internet, or you drive yourself and see what's the comfort level, what's the safety, you can read about it. So these axes you can find either from the auto showroom or from studying a bit. Okay, so and then you see, I have this kind of money, am I happy with this kind of comfort? If not, can I find some more money from loan or whatever? So go to the next one and then see I've increased my level of comfort, right? So that's how you make decision. There is always a trade-off. You go to do anything, there is something you have to put, some money, some of your time, effort, all these as one criteria. The other criteria is how much I'm getting out of it. So obviously if you put more and more, you're going to get more and more out of it, because the companies have put that kind of effort with the money that they're taking from you to produce better solutions, right? So there's, in life, there's always this trade-off. You wish you get the most comfortable one with the least price. So that means you are thinking of a solution that should be here. I want to spend 10K and I get 90% comfortable car. Everyone wishes that, but unfortunately nobody can produce that for you. Okay, so there's always this point which is known as the ideal point. It never exists, and people are trying to make a lot of effort to go towards that. So this could be one kind of setup with, let's say, one material, one technology, things like that. When technology improves, maybe this goes like that. Another improvement maybe is going like that. So we are trying to go towards the ideal point always, so that my range of cost versus comfort reduces. So I don't have to do a decision making. Everybody will get the right thing, but it'll never be possible, okay? Because you are trying to minimize this as much as possible, you're trying to maximize this as much as possible, and it'll always continue like this. Ideal point also moves with new technology and everything. But you always have this part chopped off like this, and that gives you the Pareto set with trade-offs. So you need to be dealing with trade-offs, okay, in real life. So there is a need for decision making. How do you decide whether you want B, not A, not C? So there are a lot of preference elicitations that you have to provide. So I'm going to talk to you about some of those ideas of how you can make decisions. So there is a whole literature, or rather a field called MCDM, multi-criterion. It started around early 70s, and I spent quite a bit of time with these people because I thought the multi-objective optimization has to follow up with the decision making. So unless we know that, what techniques they use, maybe we are just doing one part of it, which is just the optimization. Maybe somehow we can combine both optimization and decision making together. Okay, so that's our goal. So I'm going to talk to you about some of the methods that we have combined with optimization and decision making. And then at the end, the very last day, we're going to talk about some advanced methods, for mostly for those of you who are curious about what is currently going on in the field. Yeah, this one should have been before, but I already talked about combining EMO and MCDM methods, and then of course wrap up. So that's about the course. Okay, any question that you may have with the content? So if you are expecting a lot of machine learning, AI, no. Today, this course, we are not doing that, because many of you may have come with that thought. We will have something to talk about it, how machine learning AI can be used to improve the performance of EMO, and EMO to improve the performance of machine learning. We'll have a couple of slides about that. That's about it. But if you are sitting here and work, so if you are working in ML and AI area particularly, you will find lots of ideas here which you can use in your methods as well. It doesn't have to be ML, AI. Any other kind of engineering disciplines, you will find that you can apply them. But any quick question? No? Okay. Are all of you going to be evaluated? You expect a pass-fail grade or something? No? No. Okay. No, of course not you, but okay. We'll talk about it later, but we're going to do it anyway. So attendance are needed. So we should take maybe attendance on a piece of paper. We're going to give 4 assignments, 16% each, and 1 exam I will take at the very last hour on Friday, which is maybe 12 to 1. Okay, so day 1 will be more basics today and evolutionary optimization basics. I have put them into 2 lectures. We'll probably not be able to finish L2, but we'll at least start. And then tutorial on the home assignment 1, which you have at the very end of your booklet. Day 2 will be evolutionary optimization. We'll continue with lecture 2 and then finish that and start with multi-objective optimization basics. That will come from L3. And so HA1 will be due tomorrow morning before we start our lecture. So before 9 you submit. And then we'll talk about tutorial for tomorrow HA2. And then day 3 we'll talk about evolutionary way of doing multi-criteria optimization, because you will already have evolutionary optimization background tomorrow. And then day 3 we'll do the evolutionary multi-objective optimization. HA2 will be due and we'll give you HA3. And then day 4 it will be decision making, okay, and maybe some part of advance will come also there. And then HA3 will be due and HA4 will be given. And then day 5 will the last day, we'll do advanced methods, followed up by some nice visualization methods that Dr. Ramu and Dipanshu is going to present. And then HA4 will be due. So there is no other assignments on the last day, rather we'll have a little exam, okay.